Here you can see from example 1. Okay. So from this example 1, there's this problem. There is rainfall for 2 hours with the height of 150 millimeters fell on a watershed which has area of 1,000 hectares. And the watershed flow coefficient, the alpha, is 0.75. If the time of concentration is 1 hour, calculate the effective rainfall, or R effective, or R24 if you use it for the Mononobe equation. And then the second one is the rainfall intensity using the Mononobe equation with the constant of 2 divided by 3. So for rainfall intensity, there are different equations that you can use for calculating it, but here we use Mononobe equation, and usually we will use this equation a lot because it's the most widely used equation for calculating rainfall intensity. And peak discharge using the rational method, and then the last one, the flow hydrograph of the rational method. So you have to draw the hydrograph at the end. If you still remember from our previous meeting, there are time of rain and time concentration. So it can be seen from the time of rain, 2 hours, and time of concentration of 1 hour. It means the time of concentration is less than time of the rain. So the duration of concentration will be faster than the duration of the rain, which means the water flowing from the upstream to downstream in 1 hour, while the rainfall is still happening until the second hour. So we can conclude that the shape of the hydrograph will not be triangular because of this. So if you still remember, if we have time of the rainfall longer than the time of concentration, we will have the kind of trapezoidal hydrograph. So here for the example 1, we calculate the effective rainfall. So effective rainfall is the alpha times the total of rainfall, which is known in the question. And then we calculate the rainfall intensity, I, using the Mononobe equation. This Mononobe equation is R24 divided by 24 times 24 divided by PC, powered by 2 divided by 3. And here we have R24 as the effective rainfall. And then we have the time of concentration of 1 hour here. And then we got 39 millimeter per hour as the rainfall intensity. And then after this, we can calculate the peak discharge using rational formula, 1 divided by 3.6, because we will use the metric units, and then 0.75 as an alpha, and then rainfall intensity 39, and the area of 1,000 hectares, which means 10 kilometers square. And then we got the peak discharge of 81.31 meter cube per second. After that, we can draw the hydrograph. using this data that we know. Like we have rainfall of 2 hours duration and the time concentration of 1 hour. So the hydrograph will peak at 1 hour, and then will be constant until 2nd hour, and then will decrease after the rainfall stops. Of course, the discharge will decrease because there is no additional volume or additional discharge because the rainfall has stopped here, and then the discharge will decreasing constantly until it reach 0 again. And here we have to calculate the volume of the flow using the area of this hydrograph. So here we have trapezoid hydrograph. So we calculate the area of this hydrograph, and after that we can know the volume of the water running in the watershed is this the amount of the water is this 585,432 meter cube. So this is the example if the time of the rain is longer than the time of concentration. So how about if the time of the rain is the same with the time of concentration? Here we have the same example, but the differences only in the time of concentration. So for the time of concentration, the factors that affecting the longer or the shorter time of concentration is the properties of the watershed. So as you already see before in the previous class, like we have different shape of watershed, and then the differences in the shape of watershed can affect the time of concentration of each watershed. For example, here we have time of concentration of 2 hours, but before we have time of concentration of 1 hour. What makes it longer or what makes it faster? There are several aspects. For example, if the watershed shape is quite long, so the water flowing from the upstream until downstream have a bigger distance than the watershed shape, which is round or which have not long but wide shape, and then it can make the time of concentration longer or shorter. So it depends on the shape of the watershed. It also depends on the maybe the contour of the watershed. For example, if the upstream is far higher than the downstream, of course the flow will be faster than the area that have like small slope or small differences in the elevation. So it can also have effect to the time of concentration. And then we calculate the same thing, like here we have effective rainfall of 112.5 millimeters. It's still the same, I guess. Yeah. And then the differences will be in here, the rainfall intensity. For the rainfall intensity, because we have time of concentration 2 hours, we have smaller intensity. And then the peak discharge, we also have smaller peak discharge because we have smaller rainfall intensity. So here we got longer time of concentration and smaller rainfall intensity, and then smaller peak discharge. And if we have the same time of rain and time of concentration, here we can assume that the time base is equal to 2 times time of concentration, because here we have the same TR, or time of rain. Of course, when it reaches peak, the time is the same as the rain stops. So after it reaches peak, the rain stops. Of course, it will be decreasing. It will be decreasing until it reaches 0. So we have this triangular hydrograph. And then from this triangular hydrograph, we can calculate the flow volume of this triangular area using this equation. Half times time base, which is 2 times time of concentration, times peak of discharge. And then here we have flow volume of 368,836. Yeah, so the same rainfall can produce different flow volume, depends on the time of concentration, and also depends on the watershed properties. So about the example of hydrograph, there are only these two. But if you still remember, we have like 3 examples of hydrograph. The other one is the triangular one, but it has different length between the before time peak, and then before the peak discharge, and then after the peak discharge. And if you want to calculate it, it's still the same. The step will be the same, but the differences only it will have like time lag, which is the differences between the time of concentration and the time of the rainfall, because it has a shorter period of time of rainfall than the time of concentration. So before the water reach the downstream, the rain already stops. That's why it will have different length between the left side and then the right side of the triangle. But it's still triangular area, and then how to calculate the flow volume, it's still the same. How you calculate the area of the of this triangular thing, but the difference is only in the amount of the number here. You cannot like make an assumption that the time base equal to 2 times time of concentration, because the right side and the left side is different. Okay, do you have any questions regarding these 2 examples? There's no question. Is it clear? Okay, I will continue to our exercise. So actually, I want to give this exercise after we finish our infiltration module, which is on the last 2 weeks, I guess. But here I make it mixed with the hydrograph. So because there is this direct run of hydrograph, so that you have to study about hydrograph first, before you can do this exercise. That's why I decided to do this exercise after we finish our surface runoff module, which is now. From this exercise, you will need to open again the materials from our previous lectures, like from the infiltration, because there is this runoff coefficient, and then P index. If you still remember regarding this P index, it's on the infiltration modules, and for the rainfall intensity, hydrographs also in our previous modules. But for the DRH volume, you will need to draw the hydrograph, which is we talked about it before, like on our previous meetings regarding the triangular hydrograph and then trapezoidal hydrograph. So for this exercise, there are differences between each of you, depends on your last digit of NRP. And if you have like here, X is your last digit of NRP, but the difference is only in the watershed area. And the area can be 50, 51, 52 until 59. And the problem here, here we have rainfall stations from 4 stations. The data is already complete, so you don't need to fill the rainfall data using the missing rainfall data, no. And then here we have the time, the rainfall data that occurred for 4 consecutive hours as follows. Here we have time, the first hour, second hour, third hour, and fourth hour. The rainfall data is different on each stations, and the rain caused flooding in the river where the flood hydrograph caused by effective rainfall was triangular with a peak discharge of 30 meter cube per second and time base 25 hours. Here you can assume that the hydrograph is triangular with the same length of side on each length of with the same length on each side, like on the left and the right side. So you can assume that this time base is equal to 2 times time concentration. And with this data, first you have to calculate the average rainfall for each hour of rain events using the method that you know. This one, we already talked about it on our maybe last month meeting, and the topic of precipitation. You can calculate the average of the rainfall using a lot of methods, for example, arithmetic methods and etc. You can use it using the method that you know to calculate the average of the rainfall. And second one, from the results of the number 1, you have to calculate the rainfall intensity for each hour of rain events and draw the hydrograph. For this rainfall intensity, because you already know the average rainfall, for the intensity is the average rainfall divided by the time, because the units is usually millimeter per hour. So you can calculate for each hour how big is the rainfall intensity. And then after that, you can draw the hydrograph. This hydrograph is symbolizing the relationship between the rainfall intensity and the time of the rain. So I versus T. And then the third one, you calculate the DRH volume. this DRH volume, you can use this information here to draw the hydrograph. And of course, to calculate the volume, you have to calculate the area of the hydrograph. And then the fourth one, calculate the effective rainfall. And for this effective rainfall, after that, you can calculate based on the answers to question 2 and 4 above. Calculate the V index. This effective rainfall. The effective rainfall is the GRH volume divided by the area of your watershed. Here we have like 50, blah, 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 51, 52, or 50 until 59. Then you got the effective rainfall. After that, after you got the effective rainfall and you already draw the hydrograph, you can calculate the V index. So after you calculate the V index, you can also calculate the runoff coefficient. This runoff coefficient, the alpha, is the comparison between this surface runoff and the effective rainfall, I guess. But this regarding this and this, you can see on the material of the infiltration. There's already an example there, but here I make it an exercise to mix that example with the other thing that we already talked about earlier. For example, here you have to calculate the average rainfall, and then you have to calculate the volume of the hydrograph, not only regarding these two things which we talk about in the infiltration module. Yeah, so that's all for the exercise 3. Do you have any questions? If you don't have any question, I can conclude that maybe it's already clear for you. Is it clear regarding this exercise? So we still have like one module left. It is related to the mass curve and duration curve. And I think we will talk about it on next Tuesday, because there are still like 2 weeks left until the no, 1 week. Yes, 1 week left, and then next 2 weeks there will be a midterm exam, if I'm not mistaken. So yeah, we still have like time. We still have time to study one module more, and then there is like also an exercise, but it will not be a take-home exercise. We will talk about it like an example that we talk about, like this hydrograph example. We will use it as an example, not for the take-home exercise. So yeah, do you have any question? So my suggestion is that you can do this directly now, so that it will be finished as soon as possible, because we still have like time left for our class. But for this for today's class, from me, it's finished. I think if you have any question, you can ask, or regarding this exercise, or maybe the example from the previous one. Is it clear for all of you?
Miss, I want to ask a question. We should do it on Excel or on paper writing by hand?
You can do it on Excel, but please submit it on PDF file. So you can do it like using Word or Excel. And for the final, you can upload it with the PDF format.
Okay, thank you, Miss.
Okay, yeah, you can also do it like together with your friends, because it has the same problems. The differences only in this area, so that I hope you understand how to do this problem, because usually in the exam there is this type of question. So I hope you can understand clearly what is this, what is that, like how to calculate the volume of the direct runoff hydrograph, and then what is the effective rainfall, how to calculate the V index. I hope you can understand it more clearly, because if it's only like an example that I talk about in the class, you will not do it by yourself. So if there is this question in the exam, you will like only yeah, I remember this type of question in the example, but I haven't do it, so I cannot like do it properly in the exam. So I hope it won't happen like that. So yeah, I suggest you to do it. Yeah, you can do it together with your friends, but you have to understand it by yourself. Okay. Yeah, I think that's all from me for today. Yeah, it's quite fast. I was expecting that there will be some question from you, but that's not the case, but it's okay. Yeah, thank you for your participation in this class. I'll see you again next Tuesday with the new modules regarding the duration curve and mass curve. And yeah, good luck with this exercise. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Thank you, ma'am.
wabarakatuh.
Thank
Thank
you,
you,
ma'am.
ma'am.
Thank you.
Thank you, ma'am.
Yeah.